In this video, I'll be going through the question you see on the screen here from the 2023 Leaving Cert Higher Level Maths Paper 2. If you're looking for a different question from this paper, check out the description below. There should be a playlist there. And if you're looking for a different paper entirely, have a look around on my channel. I'll be doing all this on a whiteboard, hopefully like you're used to your teacher doing. But we are on YouTube, so take advantage of the features there. Watch it at half speed or double speed, and certainly pause and try the question first. If you find this video or any of my videos useful, I would greatly appreciate a like or subscribe, but what helps especially is sharing it with a friend that might be doing the Leaving Cert this year or next. In question 5, they set up the situation that this person has a load of little cubes, small different coloured cubes. Have a Rubik's Cube here as an example. And they're all separate. Think of each of these separate. And they're in a bag. They don't tell us how many, they say a large number. And this person, they pick out 5 different cubes and they write down their results. That's all in this table. I've left out a lot of numbers because we don't really need them all. For example, the first time they got 0 reds, 4 greens and 1 blue. The second, adding up to 5. The second time they got 3 red, 2 green, 0 blue, adding up to 5. And they did this test 7 different times. And that's it. That's the information they give you. And the first question is, work out the mean and standard deviation of the number of red cubes you get. So A, part 1. Now you could do this by hand, especially the mean. The mean is just 0 plus 3 plus 2 plus 2 plus 4 plus 5 plus 1, which I think was 17 divided by 7, and that gives you, I do have the answer here, around 2.4, 2.428 something. So you can do that by hand. The standard deviation, not so much. Well, you can do it by hand. It's this number minus the average squared, I think. But it's not that easy. So here's what you need to do. You need to learn how to use your calculator. The problem is so many calculators are different. So you do need to go on YouTube and find a tutorial for your exact calculator. Type in stats tutorial. Ask how to find the standard deviation on this calculator and type in the name of your calculator. What you'll do is you'll open your calculator and you end up just putting these numbers in. You'll have a table. X equals 0, x equals 3, and you put 7 different numbers in, and you press some button. On mine, I think I press an option button, go through a list, and it'll tell me the mean. Right, so it usually writes like this: the mean is equal, what I read out there, 2.428, and so on. They only wanted 1 decimal place, so 2.4. They'll give you lots more information, your calculator though. Do this all in one go, it will. The other bit of information is the standard deviation, often written like this, and it'll come out as 1.5907. Stay going. They just wanted 1 decimal place. 1.6 is your answer. Part 2 is somewhat similar. They want you to work out the correlation coefficient between the reds and the greens. So again, you have to go to your calculator. Slightly different setup. You need to put in 0 and then 4 in another column, 3 and then 2 in another column, 2 and 0, 0, 3, 0, 0 and 2. All of these in 2 different columns. And again, just type some buttons in your calculator and it will give you OR. It'll usually give you a few numbers, but one of them is OR, and it will come out to be minus 0.76204. How many decimals do they want? Just 3 decimal places. So that would be minus 0.762. Then the final part of part A. This question stumped me at first. I was a bit confused by what I wanted. But they said if you repeated this experiment lots of times, explain why you would expect to get a negative correlation each time. So here's how I finally figured it out or thought about it. Is I drew it as a picture, and that's what you're inside your calculator. It's putting all these 0, 4, 0, 4, 3, 2, and so on. I don't know what it looks like. It looks something like this, but it has this negative slope. And I looked at that and I thought, why is that again? And there's a reason why you would get this sort of shape each time you did this experiment. And it's nothing to do with there being more red than green. There does seem a little more red than green by adding the numbers up, but can't guarantee. There does seem less blue, but again, it doesn't matter. The simple thing is, if you take 5 cubes out, if 5 of them are red, then you're down here on the x-axis, the red axis. Sorry, red and green. If you get 5 reds, well, you have to get 0 greens. If you get 0 reds, well, you might get blues, but there's much better chance now to get greens. So they're just, that's all they want you to say, something like that. If you get more reds, you have to get less greens. There's just less choices. Think of it, you only pick 5 blocks out. If one of them is only one of them's red, now there's 4 chances to get greens. There's a lot of chances there. If 4 of them are reds, well, there's very low chances to get greens. There's only one opportunity. Might not even get it. Anyway, that's what they wanted. More reds mean less greens. More greens mean less reds. You'll get a negative thing. I thought that was a quite hard one. That probably would have stumped me in the exam. I had to think about it for a while. In the exam, I probably would have left it and might not have got it. Okay, in part B, it's not actually that hard of a question, this, but it's a bit of a long explanation. So if you have trouble with English, this is going to be a lot of trouble for you because you have to read a lot of this. We have a cube like this. That's why I had a Rubik's Cube earlier. Very similar to a Rubik's Cube, except instead there's 5 across. There's 3 back and 4 high. So it's a little bigger, it's stretched out a bit in different directions. But they talk about each of these individual cubes and how many faces touch the air or can see the light, as it were. And for example, like this cube here, 2 of its faces can be seen. The cubes on the corner, 3 of the faces can be seen. This cube here in the middle, only 1 of its faces can be seen. And there must be some cubes in the middle that can't be seen. For a Rubik's Cube, it has 8 corners with 3. It has, I guess, is that 8, another 8 ones, and there's only 1 guy in the middle of different things. This guy, we just have to add it up. Very similar ways. They give us a table. They did ones for us. So that's this 1, 2, 3, 4, 5, 6, 7, 8. There's more at the back, another 8. So that's 16. There's 3 at the top, another 3 at the bottom. That's 22. They added up. The 3 corners are much easier there. Just 1, 2, 3, 4, 5, 6, 7, and the 1 at the back we can't see. That's 8. The 2s, again, and that's all I'm doing here. I'm just counting up and just being careful. There's 1, 2, 3, 4, 5, 6, 7, 8. 8 on top, 8 on the bottom. That's 16. But then don't forget there's 1, 2, 3, 4, 5, 6, and the 2 at the back, 7, 8. So 16 plus 8 is 24. Just checking my numbers here. Yeah, that's right. The last one, the ones that are in the center you can't see. You can add them up if you're good at spatial awareness. You can think, well, there's 2 here on the inside, and there's 6 here. But you have to go 1 back from that. And they're the only 6 you can see, yeah. I didn't explain that well at all. I'm seeing it in my head, but I don't know, I'm not explaining it well. But there are 6 in the centre that can't be seen by anyone. But you don't need to be good at spatial awareness for that. We can just add these up and we will get, these guys here would be 54 of them. And what's the total number of cubes in this? 5 times 3 times 4 is 60. All of this has to add up to 60. So this guy has to be 6. 2 ways to do that. And that's it for question 5. If you have any follow-up questions, let me know in the comments. I'll do my best to answer. Thanks for watching. Have a great day.